Hey everybody, welcome to part 1 of the 856 part series on Instructional UTEM. Today we'll be talking about running a tensile test. We're going to start by locating our wedge grip with the M48 threaded end. Insert this into the center of the T-slot table, rotate it counterclockwise to tighten it all the way to the end, and then rotate it back to its desired testing orientation. Grab a set of Tommy bars, tighten the lower lock nut by hand, and then use the Tommy bars to tighten fully. Return the wedge grip to its desired testing orientation. Go ahead and grab the wedge grip with the clevis pin male end, insert that into the female end of the load cell, tighten the lock nut, and then use Tommy bars to fully secure. For now, we're going to grab whatever jaws we want to use. We have our choice of 0 to 1/4 inch or 1/4 inch to a 1/2 inch. We can start by removing the securing attachment with a hex wrench, and then we'll slide the jaws in, making sure that the hook bend goes around the platform of the wedge grip. Now you'll notice there's pins on the backside of the jaws. These will go into the spring insert on the backside. Simply do this by pulling down on the spring and then making sure that the pins go all the way through. Replace the securing attachment, and now our fixtures are installed for a tensile test.
Ooh, tension!
At this point, we can go ahead and get the frame ready for testing. Release the emergency stop button. You'll notice there's a red light on the frame standby on the control panel. I'll talk about how to fix that in a sec. After that, we can adjust the mechanical limit switches, move them to a point which the grips won't touch, but will be safe for testing. So go ahead and open Blue Hill Universal if you haven't already, and then we'll click the frame icon in the top right, and then we will click Enable Frame. That will get rid of that red light on the frame standby that we saw earlier, and you'll also hear a click that lets you know the software is communicating with the frame. While we're here, let's go ahead and calibrate the load cell. We'll click the load cell icon, and then we'll click Calibrate, and then we'll click OK. When we do this, make sure that we're not touching the load cell or the fixtures, or that the specimen isn't already loaded. We can now proceed to install our extensometer and get that all set up ready for testing. So if you notice that in the case there's a bunch of different clips, the clips on the left side of the case are for flats, clips on the right side are for rounds. The sample I'm going to be testing in this demo is about 6.2, 6.3 millimeters thick, so I'm going to select the middle flat clips, which are 6 to 9 millimeter options. However, during this test, the extensometer clips actually slipped, so I had to retest, and in that case I dropped down to the 3 to 6 millimeter options, and therefore we got a good test. Now, dropping down a size doesn't really hurt anything, but do know that that will put more force on your sample, which can lead to it prematurely breaking. This is especially important when you're testing plastics, in particular thin plastics, and our breaking point might actually move before the yield point or the theoretical yield point, and our extensometer can fall off when it does break, which is bad because then the extensometer breaks and we no longer have an extensometer. Now that we have the clip selected, we can finish setting up the extensometer. The extensometer is very sensitive, so when you are holding it, make sure you're holding it by the little cone thingies on the side. Go ahead and slide the clips in so the little notch lines up with the notch on the extensometer. Go ahead and plug the extensometer connector into the strain 1 card on the Instructional. Make sure that the connector is aligned correctly and that no pins are broken during this process. Straighten out the extensometer cable, make sure there's no kinks or knots in it, and then we will remove the yellow magnet and lace the cable through it. And when we do this, we want to make sure we have enough cable length that the extensometer will be able to go through the full range of testing. Now you'll notice when I'm done with all that, I'm going to put the extensometer on the yellow magnet through the hole provided. This is the appropriate storage position when the extensometer is not in use during testing. Just like we did with the load cell, we also need to calibrate the extensometer. We'll click the frame in the upper right hand corner, then we'll click the extensometer icon. When we calibrate the extensometer, we do need to make sure that the extensometer is set at its gauge length. We do this by holding the cones that we should be holding the extensometer by anyway, and also making sure that the extensometer is held steady. Then we can click calibrate and then OK. Once it's done calibrating, we should now see a strain reading on the strain 1 channel, and at this point we can go ahead and return the extensometer to its storage hanger. Now that we have all our tensile fixtures and equipment installed, we can begin to create a test profile. So one of the easiest ways to create a testing profile in Blue Hill is to start from a template. So we'll first start by going to Method, and then we'll type in E8, which is the ASTM standard for metallic tensile testing. And then since the material I'm testing today is an A36 steel, I know that it's going to have a discontinuous yield, so I will go ahead and select that option for E8. The software is going to give you a prompt saying there's some errors. Don't really worry about this, just click OK. And then immediately we can click the floppy disk icon at the top and click Save Method As, and then we can save it to our favorite storage location. And then we can go back to the main menu, and then now we'll click on Test. In this window you should be able to see the test method you just saved. Go ahead and open that now, and it'll give you a prompt to adjust the limit settings. Don't worry about that for now, we'll adjust those before we actually start the test. Go ahead and click at the Method tab at the top, and this is a method I previously created, so I'll go ahead and walk you guys through all the settings I put in for this specific test. Blue Hill kind of creates a workflow at the top under those sub-tabs, and you should basically move left from right in order to create your test profile. But I can start by saying you can pretty much always ignore the first 2 tabs unless there's some quality assurance thing you want to do that would require them, but for the most part you don't need to worry about them. So go ahead and start in the 3rd tab, which is the Specimen tab. Now in the Specimens tab, probably the only page to worry about is the Properties tab. These are the properties of your individual specimen. Blue Hill refers to sample as a group of specimens. Specimen is your one specimen, that'll be your one test. But a sample would be a group of tests or a group of specimens. So if we're making edits to our properties page in our specimen tab, these are the properties of our individual specimen. Now if we're testing a bunch of specimens, we would want to change this every time. But there is an easy way to do that, which I'll show you later on in the video, and that just goes through the test tab. Now moving on to the measurements tab, these are going to be all the measurements that the system records during your test. Now, if you'll notice that we have two strain channels, but really we just have one. We have our strain 1, which is from our extensometer, and our tensile strain is a mix of our extensometer. Once we remove that extensometer, it goes off of our displacement from the crosshead. In the calculations tab, these are going to be all the results of our test. So for example, modulus or tensile strength, all of the calculations that are based on the data we just observed during our test. To add or remove which calculations you want the system to calculate, simply click the arrows in the middle. By clicking on the domain at the bottom of the screen, you can choose limits about which these calculations are taken over. For example, if you wanted the maximum force between 0 and 5% strain, you could set that as your domain and it would give you back the maximum force in that region. You'll also notice that this specific domain is a function, meaning it can be a function of other calculations. So in this case, it's ramp 1 until the end of data. Ramp 1 refers to our test ramp, which we'll determine in a sec. Moving on to probably the most important tab is the test control tab. Our first page is the start test, and basically under all circumstances, we're just going to leave that on with the start button. The strain page is very important, especially if you're running a strain control test. Since we are using a clip-on extensometer for this test, we do want to make sure that it is removed during the test. So what we're signifying on this page is our criteria for removal of the extensometer. At that point, it'll transition to using crosshead displacement. Right now I have it set up to be removed at 4% strain. However, there is other options. I could use tensile stress. Since it is an A36 steel, I know the yield point and I know the tensile strength. At least I know the minimums according to the ASTM standard. So looking at the beginning phases of a tensile graph of an A36 steel, I could, if I wanted to, set my extensometer removal point as something above the expected yield stress, after the discontinuous yield, and below the ultimate tensile strength. For now, let's just keep it at the 4% strain to keep things simple. In the pretest page, the two important things are the preload and the auto balance. Our preload is actually going to be the trigger that starts the test. Any data before this is not recorded. I'll explain more on this in the compression and bend videos, but basically just think of this as a trigger for you to actually start your test ramp. Your auto balance is also important because this is going to basically zero whatever you want when you hit your preload threshold. Now, for running a tensile test on metallic samples, we don't want to auto balance force because we want any force that we put on prior to the test to be included with our data. However, we do want to auto balance the strain and set that to 0 at the start of our test. Our test page is going to be how our frame behaves while we're recording data. For this specific test, I'm going to use two ramps. Ramp 1 is going to be while my extensometer is attached, and that'll go at the specified strain rate according to E8. And then ramp 2 is going to be after I remove the extensometer, and with that I also need to make sure that my changeover rule is on extensometer removal. If I wanted to run a test as, say, stress control or force control, I could do this here by changing the control mode. Where it says estimated strain rate, I would just change that to my desired control method of choice. Bluehill will let you put up to 4 ramps in a single test, and these can alternate back and forth between displacement, force, and strain control. However, you can't move between tension and compression, meaning the crosshead is only allowed to move in one direction during your test. Also remember, when we're setting up our calculations, the domain of one of those calculations was from ramp 1 until the end of data. Ramp 1 signifies that test ramp. So if you wanted a certain calculation over different ramps, that would be how you adjust it, and you would adjust that back on your calculations page by adjusting the domain. One of the last things we need to do, at least in terms of test control, is determine our end of test, which is basically a way of saying what event is going to tell our software that the test is over with. Right now I have two criteria to determine end of test. One is the measurement rate for force, and that's set at 40%, meaning that when my force drops below its 40%, aka fracture, then that would signify the end of test. The other criteria is a measurement level, and that's off of displacement, which is set to 100 millimeters, which in theory this test should not go that far at all. So really this is acting more like a software crosshead travel limit. Now, because I have two end of test criteria, the test will stop based on whichever one of these events occurs first. You can add up to 4 end of test criteria. Do this by first activating the end of test, then selecting the appropriate criteria. Then you'll need to select your appropriate measurement. This will be what signal you want to go off of and the appropriate value for it. Now you notice some of these have an activation level. Consider this like a threshold that you need to reach in order for that end of test criteria to come into play. The last page in this tab is the data page, and for the most part you don't really need to worry about it. You would ever really need to worry about it if you're running a super fast test and you need to make sure that you're capturing all the important data, or if you're running a super slow test and want to cut down the file size. Moving on to the last couple tabs, which are basically all about your workflow and your user operation. Live displays are going to be your live readings, which you see at the top of the screen. Do the same thing as before with the arrow keys to add or remove them. You can also drag up and down to reorder them if you so choose. Soft keys are going to be the buttons you see in your test panel. These buttons are useful for things such as balancing your load cell, zeroing displacement, or returning to home after a test. On your frame page, you can basically leave everything as is. If you notice, there is a specimen protection. I personally don't like this, but if you want to use it, you can. You would also need to enable it on your end of test page. Basically what this does is it creates a feedback loop from the load cell, and it'll automatically adjust the crosshead based on how much force is being applied. This can kind of be a pain depending on what you're doing with it, which is why I personally recommend not using it. I would also recommend leaving the return destination to 0, because when you hit 0 displacement, that sets your new 0. So when you hit return to home, it'll go to your previous 0 plus whatever value you have in here. This can again create some issues. The grip page is for setting pneumatic grip parameters, which we don't have, so don't worry about this page. In your workspace tab, your first page is going to be your operator inputs. These will be things that you change prior to testing each specimen. As I mentioned earlier, since the specimen dimensions might change with each specimen, it's much easier to edit these dimensions from the test page rather than editing the method every time. These will be the numbers that are used for your calculations and your output data, so it's very important, particularly in the cases of running a stress control test, that these numbers are accurate, and therefore your test will run smoothly. In this case, I have the length set to 60 millimeters, which is the reduced length of my dog bone sample. This may be something that needs to be adjusted for each type of test, because regardless of how you do this, you're either going to get an overestimation or an underestimation based on the crosshead displacement when you are working with a dog bone sample. This is because if we go off of the distance between the grips, then we have an underestimation because the wider portion of the sample will not have as much strain as the reduced section. On the other hand, if we go off of only the reduced section, then there's still some strain that's occurring in the wider sections. This will be something that you need to adjust based on what you're trying to achieve and your individual materials. Also remember that what I'm referring to here is the strain after we remove the extensometer, and the strain becomes based on crosshead displacement. While the extensometer is still on, the strain is accurate. For this reason, standards such as ASTM D638, which is Tensile Properties of Plastics, actually explicitly prohibits the use of crosshead displacement in calculating your modulus. Moving back to your results page, these are going to be all the calculations you previously set in your calculations tab. You'll notice that there's a results 1 and results 2 page. This is if you want to group your results separately. How you export these will be determined in the next tab, which I'll go over in a sec. The graph 1 and graph 2 pages are your live readings during your test. Normally you'd be able to see your graph 1 and graph 2s in your test tab. However, since we have a workflow type test method, it's not going to show that immediately, but I'll go through it in the other videos where you'll be able to see that. In order to adjust these graphs how you'd like them to look during the test, you can click at the soft keys at the top and edit accordingly. You can change your units, and then also you can change your scale. If you have a relatively good idea of what your scale is going to look like, I would recommend setting it manually, because as you'll see when we're testing, the auto scale can do some kind of funky things that may make you think your test is running incorrectly. In your raw data page, this is where you'll select the measurements that you want to eventually export after the test. Even though we already selected what measurements we actually want to measure, they won't export unless we select them here. I would personally recommend adding everything we can. It's way better to have too much data and not need it than it is to not have enough data and need more. As I've mentioned before, Blue Hill is mainly a QA type software. So the pass-fail refers to your QA bounds. If you do want to add these, go back to the results 1 page and then add your failure bounds. But I'd imagine for most people using the software, this doesn't really concern them, so just ignore it. The layout page is where you'll adjust your live display during the test, and I'll talk about how to adjust this more in other videos. Moving on to your export tab, this is probably one of the most important things because this is actually going to be how you're going to get your data. So for the export here, I'm going to show how to auto export after a test with a single file for each specimen. So first thing we want to do is set export 1 frequency to after each test. Then next we'll check the override default folder slider, and then we'll set export file 1 folder to wherever we want to save the file to. For now, I'm going to save my file name as my sample name. Under content, we want to make sure all sliders are checked for whatever values we want in our export file. So for this example, I'm going to use parameters, results, and our raw data all in the same file. This would be where if I wanted to export my results and my raw data separately, I could set export 1 to my results and export 2 to my raw data. Very last thing we need to do is go to our workflow tab, and because we start from a template, it'll be much easier because it's already basically preset for us. But the one thing I am going to switch is the number of specimens in a sample. I'm going to change that to 1, so that way each test is our 1 specimen and our 1 sample. When we're all done with this, make sure we save the method by clicking the floppy disk at the top. Now that our test method is all set up, we can load our specimen. First thing we're going to do is move our grips to the appropriate position based on the length of our specimen. We'll do this by putting our specimen up to our jaws and then using the control panel on the Instructional frame to move our grips into the appropriate position. On the control panel, there's a jog up and jog down arrow. These are our coarse adjustments for large movements. And then we also have a roller that we can use for fine positioning for small movements. If the frame isn't responding to the control panel, double check that the frame is still enabled. We want to use at least 2/3 of the jaw face for gripping our specimen. We also want to make sure that the jaws are not gripping any part of the reduced section of our sample. Note that we're not actually loading our specimen here, we're just moving the grips to the right position, and we want to get a good idea based on our specimen length. Before we actually install the specimen, we need to do 2 things first. The first thing is we're going to click the 0 displacement, and then we're also going to balance our force so that our load cell is zeroed out. Go ahead and start by turning the spokes on the wedge grips to open them up, and then we can go ahead and insert our test coupon. Keep in mind that 2/3 rule that I mentioned earlier. I prefer to start with the bottom wedge grip, so I'm going to insert my test coupon and then tighten the spokes to secure the sample. If you notice, you'll also see me wiggling it back and forth. This is to make sure I'm trying to get the test coupon as vertical as possible, and that way we have the best chance of getting a perfectly uniaxial test. And I'm actually going to use a leveling bubble to double check that my sample is vertical. Once this is all good, we can go ahead and tighten the top wedge grip. Keep in mind that when we tighten the top wedge grip, this is usually the point where we'll impart some force onto our sample, and our force and stress reading should rise at this point. Remember that we've already balanced the force, so we don't want to do it again. Any stress that's on the sample as it is now should remain there at the start of the test. If you notice the stress on the sample now is about 21.5 megapascal, this is okay because according to ASTM E8, the starting stress on the sample should be below 10% of the nominal yield. An 836 steel has a nominal yield requirement of 250 megapascals, so we're still good according to the standard. With the sample loaded, we can now add our extensometer. In order to do this, we'll use the two-hand method. With one hand, we're going to press on the cone latches, that'll set our gauge length. The other hand, we're going to use two fingers, we're going to bend the prongs outward and then slide around our sample. You'll notice in the diagram that the extensometer has specimen stops on it. However, at the time of this video, our extensometer does not have these installed. The reason they're not installed is because the position of them depends on the sample reduced width. Therefore, if we're testing different materials that have different reduced widths, then we would need to change it every time. So we'll kind of go with the hard method, and that is by lining it up manually. What we want to do is make sure the knife edges are centered on the sample from the front side, and then on the back side, the points on the clips should be centered with the specimen. After we've added the extensometer to the specimen, we don't necessarily need to balance the strain because if you remember during our preload, after that criteria was met, we have an auto balance of our strain. But if you wanted to, just click the soft key at the bottom that says balance strain.
Are we there yet?
Almost. The last thing we need to do is adjust our mechanical limit switches to the range of our test. Okay, now we're good to start our test. So what we'll do is we'll click before test, then we'll enter in all of our specimen properties. Then we'll click the red play arrow, which starts the test. More than likely, you'll notice a super squiggly line at the start of the test. This is just noise, and is one thing that having a manual scale can help fix. Because as you can see, as the test progresses, the line becomes more linear and is more of the behavior that we would expect from the step of test. While the test is doing its thing, I can point out that this is the layout that you would set up when you're developing your method. Right now I have two graphs, top one being stress and strain, bottom one being force and displacement. And this is the point of the test where we've reached everybody's favorite part.
Yield.
And if you notice that the yield behavior on the graph was kind of doing some awkward things, that's just another side effect of using the auto scale. So basically at this point, I'm good to remove my extensometer at any point. However, if you remember, in my test method, I set it to remove at 4% strain. So we need to let the test run out until then. At 4% strain, we'll get a pop-up on the Blue Hill software. It doesn't show up on here because the screen recorder didn't capture it, but it says something along the lines of remove extensometer and then continue test. So we'll remove the extensometer, making sure to put it back on its storage hanger, and then we'll click OK and continue on with our test. You'll notice at the top of the Blue Hill UI, our strain 1 channel is locked at 4%. That's because our strain 1 is our extensometer. It's still measuring strain, it's just now going off across that displacement. So in hindsight, it probably would have been better to put a tensile strain channel as the display on there instead of just the extensometer strain. When the test concludes, our calculations will auto-populate. It'll draw a line on the graph indicating the slope of our modulus, and then in our results 1 panel, it'll give us our modulus and then also the statistics of it. However, we just have one specimen, which is why there's no standard deviation or coefficient of variation. And again, in hindsight, it probably would have been a lot better to have the modulus reported in gigapascals instead of megapascals. And then when we go to our desktop, which is the folder I chose to save this data to, our data from this last test will appear. It is a CSV file, however, Excel is not installed on this computer, so it'll open in Notepad. You'll notice at the top of the file I have my methods, followed by my results, followed by my raw data. If you want to add more method parameters than I have here, go to your export window, and then go to export 1, and then at the top you'll see method parameters, and then you can use the arrows to adjust whatever parameters you want in your export data. And that's about all there is to this test. If you want to run another test, just repeat the process. You don't have to go through the whole method, just go back to the test page and click start. Now if you are done with all the testing, do these few simple things. On shutdown of the machine, set the mechanical limit switches to the crosshead position, and then set the e-stop, and then followed by turning off the breakers of the machine. Lastly, turn off the computer. The upper wedge grip should be easy. Simply undo the lock nut and remove it from the clevis pin. With the lower wedge grip, all you need to do is loosen the lower lock nut. Then you can grab the wedge body, rotate it clockwise to spin it out of the thread. You do not need to adjust any of the other lock nuts on the wedge grips. And there we are. That's all there is to this tensile test.